Hey everyone, and welcome. So you're looking to get started with Java? Awesome, you're in the perfect spot. We're going to strip away all the complicated stuff today and get right down to the basics, the absolute foundation of the language, how it handles information. All right, let's just dive right in. So let's start with a really simple question, but honestly, it's probably the most important one in all of programming. Think about it. When your program needs to know a user's score is, say, 100, or that their name is Alex, how does it actually remember that? How does it hold on to that information so it can use it later on?
Well, it's actually pretty simple. The easiest way to picture it is that your code uses little containers. You can think of them like little boxes, and their only job is to store pieces of data. If you can get your head around this one simple idea, this analogy, I promise it's going to unlock everything else for you.
Okay, so let's give these containers their proper technical name. In the world of programming, we call them variables. And that's exactly what they are. They're the fundamental way we store, look up, and actually do stuff with information in our code. All right, here's the more official definition, but you'll see it lines up perfectly with our little container analogy. A variable is just a named spot in the computer's memory. That's our container, and we can put a value in it. Now, that named part, that is absolutely crucial. That's the label on the box. It's how we find our container again later when we need to know what's inside.
But here's the thing. It's not enough to just have a container. I mean, think about it in real life. You wouldn't store water in a paper bag, would you? Or, I don't know, keep your keys in a giant fishbowl? Of course not. You have to choose the right container for the job. And guess what? Programming is exactly the same. We have to tell Java specifically what kind of data our container is built to hold.
And this is where our analogy really starts to pay off. So let's say you have a simple whole number, like 10, or 25, or 42. Think of that like a water bottle, right? It holds a specific whole amount. In Java, that kind of container is called an int. Okay, what about a number with a decimal? Something more precise, like 98.6. For that, you need something more like a measuring scale. In Java, we'd use a container called a float. And finally, for text, like someone's name, a name tag is a great way to picture that. And in Java, that's called a string. Okay, let's see what this looks like in actual code. This single line here is a complete instruction to the computer. It's like we're saying, hey Java, I need a container that's built to hold a whole number. That's the int part. Then I want to label this container age. And finally, please put the number 25 inside it. See? It's really that straightforward. And here's the other example we talked about. It's the exact same pattern. We're saying, all right, Java, new container. This one needs to hold text, so make it a string. We're going to call this one name. And go ahead and put the word John inside. And just like that, we've stored both an age and a name. They're sitting there in memory, ready for us to use whenever we want. Now, these are really simple container types, like our int for whole numbers. They have an official name. They're called primitive types. And honestly, the best way to think of them is like the most basic individual Lego bricks. The little square ones. They can't be broken down any further. They are the absolute simplest, most fundamental building blocks that Java provides. And this brings us to a really important distinction in Java. So, you have your primitive types. The int, the float, they're like the Lego bricks themselves. They just hold one simple value. But then, you have non-primitive types. These are more like the cool, complex things you build with the Lego bricks. And you might have noticed string is on this side. Yeah, even though it feels pretty simple to us, behind the scenes, it's actually a more complex thing called an object, which gives it a bunch of extra powers we can use. Okay, let's recap. We've got our containers, which we now know are called variables, and we know how to pick the right type of container for our data. Awesome, but what's the point of just storing stuff? We need to be able to do things with it, right? And that, my friends, is where our Programmer's Toolkit comes into play. Here's the best way to frame this. If our variables are the nouns in our code, the things, the data itself, then operators are the verbs. They're the action words. These are the symbols that actually perform actions on our variables. Operators are what make our programs come alive and actually do useful stuff.
And here are the big ones, the ones you're going to be using all the time. Of course, you've got the basics you learned in school, plus, minus, times, divide. Easy enough. But there are a couple of other really handy ones. That percent sign, that's called modulus, and it's a cool trick to get the remainder after a division. And then you've got plus plus and minus minus, increment and decrement. They're just super convenient shortcuts for adding or subtracting one from a number, which you do a lot. So, we've talked about containers and data types and these action words called operators. But what's the big takeaway? What's the crucial point here? Why does any of this stuff actually matter when you put it all together?
It all comes down to this. Learning this stuff, it's not just about memorizing some weird symbols and keywords. It's about learning the fundamental language of how to solve problems with a computer. I'm serious. Every single complex app, every video game, every piece of software you've ever used is built on this exact foundation. Storing information in the right kinds of containers and then using operators to do things with that information.
So there you have it. You now have the 3 core building blocks of the Java language. You've got the tools. The only question left is, what are you going to build with them? Thanks so much for joining me.